In the previous section, we worked with fractions that had the same denominator. This meant that everything was evenly spaced in the pictures that we drew. However, if the denominators are different, then the spacing becomes very uneven. Here's a picture of two number lines side by side using 1/3 and 1/4 as the spacing. Notice that the two spacings don't line up with each other except at the integers. This would create a problem if we were trying to do a calculation like 1/3 plus 1/4. We can go from 0 to 1/3, but trying to move 1/4 to the right of that value doesn't make sense because it doesn't fit on the picture. Instead, we need to pick a picture where the points are evenly spaced and where the picture also contains these points. The correct denominator to use for this process is the least common denominator of 3 and 4, which happens to be 12. Let's see what this picture looks like when we take these values and put them onto a 1/12 number line. Notice that all the points that we started with transfer over to the new number line perfectly. This is the logic of why we need a common denominator for addition and subtraction of fractions when the denominators are different. We need everything to have the same step size. Example, compute 2/3 plus 3/4. These two fractions have different denominators, so we need to write them with a common denominator. The least common denominator is 12, so we will rewrite each fraction by multiplying the top and bottom by the correct value. We have to multiply the top and bottom of the fraction 2/3 by 4 to get a denominator of 12. So 2 times 4 over 3 times 4. And for the fraction 3/4, we need to multiply top and bottom by 3. 3 times 3 over 4 times 3. When we do the arithmetic, we get 8/12 plus 9/12. Now that they have the same denominator, we can just add. 8 plus 9 is 17. The answer is 17/12. Notice that we are maintaining the presentation of keeping the equal signs lined up. We also wrote out the multiplication on the top and on the bottom. Do not get lazy and write it in only one place. That is an improper notation and will cause confusion later on when we start multiplying by fractions. Remember that the symbols have meaning and what you write matters. Example, compute 5/9 plus 5/6. What is the least common denominator of these two fractions? If the number 54 came to mind, you found a common denominator, but it was not the least common denominator. It wouldn't be wrong, but you would end up having to use numbers that are much larger than necessary, and you have to have an extra reducing step in the end. It turns out that the least common denominator is 18. 5/9 plus 5/6 is equal to, we need to multiply top and bottom of the first fraction by 2 to get to 18. And for the second fraction, we must multiply top and bottom by 3. 10/18 plus 15/18 is 25/18. Example, compute 3/4 plus 5/8. What is the least common denominator of these two fractions? This one sometimes throws students off, but the least common denominator is 8. 3/4 plus 5/8. For the first fraction, we need to multiply top and bottom by 2. But for the second fraction, we don't need to do any multiplication at all. It already has a denominator of 8, so we can just leave it alone. 3 times 2 is 6, 4 times 2 is 8, and so this gives us 6/8 plus 5/8, which is 11/8. Example, compute 2 minus 3/5. When working with integers, we can always write them as a fraction with a denominator of 1. This means that 2 minus 3/5 can be thought of as 2 over 1 minus 3/5. And now we find the least common denominator, which is 5. And then we do the calculation from there. You will be very tempted to not write the original problem and simply start off by writing 2 over 1 minus 3/5. Avoid that temptation and take the extra couple seconds to rewrite the original problem as it was given to you, 2 minus 3/5, and then do your calculations from there.